Hey guys, doing another problem from this blind 75 list. This one is remove the nth node from the end of list. I guess this is a medium one. Nth node from the end of list. Why is not an easy one? Like it's just a traverse the list and remove the node from the end. I guess they want maybe even more optimization, but let's see here. So given the head of a linked list, remove the nth node from the end of the list and return set head. So for example, in this is the list, head equals to this, n equals to 2, output equals to this. So head was one. So you are given 1, 2, 3, 4, 5 as a list. You want to return the second element from the n. So return 1, 2, 3, 5. Yeah, okay. And this. Is there a, could you do this in one pass? There is this follow up. So I don't know whether I can think of this or not, but first I'll wanna do, like, I wouldn't want to be too smart and just do the basic thing, right? So okay, it's a singly linked list, so I do not know the um, I do not know the, if I want to get the nth element from the end, I would want to um, get the um, length first, right? And first I get the length. Okay, so let's first do that. So get list length and we pass head. So how can we get length? So let's call this function int and we do, oh, isn't the length n? It's given. Okay, no, n is not, n is something else. Okay, and so we get list length, list node head int count equals to 0. So while head is not equals to null, okay, you do count plus plus head equals to head next, and whatever many you count is your length. Sorry about that. And now what you want is so you want the index of the node, right? Essentially that's what you want. So index of the node is length, yeah, length is the total length minus n. So for example, in this case your length would be 5 and this n is 2, so 5 minus 2 is 3. So 0, 1, 2, 3 is where you want to go to, right? So now you go return node at index, so you pass head and you pass index, and so now your list node at index, you do this node head, you index, and while I guess true, or rather while, so current index equals to 0 and current node equals to head. So while your current index is less than the index, you do current node equals to current node dot next, and you do your index plus plus. And once your current index is equal to the index, sorry, yeah, current index. So for example, if you want to return index 0, then 0 less than 0 will be false, you'll directly return this. If you want to return index 1, then first time 0 is less than 1, so you'll move one step ahead, current index will become 1, current index is already 1, so 1 is not less than 1, so you return, yeah, so this is fine, so you return current node. So this is the basic thing. Let's quickly submit and see if this works. and obviously you get some issue. It's not int, it's list node. And submit, and you get a wrong answer. Okay, there's probably, okay, let's see, 1 2 3 4 5, output is 4 5. Okay, I think you missed one thing. I think you have to return the head only and not the node that you are removing. This is what you removed, but you don't have to. Okay, you have to remove the node, not so instead of node at index, you call it remove node at index. Yes, we understood the problem incorrectly. Problem was not to return the nth node, but problem was to remove the nth node. Okay, so remove node at index, and we go okay, remove node at index, and you have to return the head list. Fine. Now, okay, so remove node at index, list node head and index. Now, I feel like I might need like a previous as well because I'm removing something at index this. That means I'm gonna link its previous guy. Yeah, but I will handle everything in this now. Okay. So some basic stuff, which is if my head is if my index is 0, then I just want to return like head.next, right? If you remember the first guy. Other than that, it's all fine. You will always be returning head. So that's taken care of. Now all you have to think about is uh, deleting the node, and what that means is um, pointing its previous to its next, right? So you get the node, but you also keep track of the previous. So this is list of current node, and then you also do this node previous node, and you call this initially as null. Right now, you wanna keep run this loop till your current node is on that node, and your previous is no previous guy. So this is all good. So your um, yeah, so this will ensure that your current node is on current node. So one thing that you have to do is before you change your current node, you can do your previous node equals to current node, and then once you come out of this loop, you have to what you have to do is previous nodes next equals to uh, current dot node next. That's how you link, right? And you return head. Okay, let's run test cases, see if it really works or not. Obviously I have some doubts. Okay, it works. Submit. Cool. Now let's think a little bit about the follow-up. Could you do it in one pass? That would essentially mean that you don't get the length, or uh, you do something like that where you reach the nth node from the end, like you do those questions where hey, find the middle node, and you find the middle node by taking two pointers. One jumps faster, the jumps slower, and that sort of nonsense, right? uh, can we do something similar here? Once, so basically I want to do something such that uh, okay, let's see. Essentially, one of the indicators would be, hey, my one of my nodes reached the end. Like, let's say if I use some two-pointer technique, then what we have to do is when one pointer reaches the end, the other pointer will reach the nth node from the end. Can I do that somehow? Reach a node reaching the end is just this null. Okay, so is there a way that I can think of? Let us see. So this is n minus, so if length is L, so L minus n and n, these are the distances, right? So if the node is at n distance from the end, then it is at L minus n distance from the from this thing. Now what if, what if it says 2, right? So in this example, I think I'm getting I think I'm getting it. So basically whatever it says, that much distance you already travel and wait. So uh, essentially, so let's do this. So it was 1, 2, 3, 4, 5, and the ask was second node from end, right? So ask was second node from. So you what you do is you go to the second node from beginning. That means here, and now you do this thing. What you do is this: you travel. Now you start another pointer from the start, right? And now you do this guy moves till the end. So this guy will move till 1, 2, 3 steps, and this guy will move 1, 2, 3 steps, and it will reach here, right? So when this guy reaches the end, this guy will then reach the this thing, right? Let's take another some random example. So 1, 2, 3, 4, 5, 6, and 7. And the question is, let's say, simple third node from the end. Okay, third node from the end. Let's make one more. So third node from the end is this is 1, this is 2, this is 3. You want to reach to 6. So whatever distance you travel from here, you travel the distance already from the top. So third node from here would be this. So you reach here, and now you start another pointer from the start of the list. And this pointer now move them together. So this will move how many distance? 1, 2, 3, 4, 5. So this will move from here 1, 2, 3, 4, 5 and reach the guy. So you got the gist, right? Come on. So that's the idea. So now we do that in single pass in that manner. So for that, we get rid of this getting the list bit. We keep these things intact. Sorry about that. You don't want to get the list length. You don't want to get the index or something like that. Now we go remove node index, and now here, uh, whatever we will treat this as whatever this is, and we call this n, and maybe here, okay, index. Now, when we're talking about index here, this is an index from the n. Okay, starting from 1. So second means 1, 2, right? So how much ever this is first you want to reach that node. That's your primary goal is just reaching that node, and uh, and maintain the previous as well. So let's do this helper node. So, and let's reach this head, and this I want to move. Yeah, man, this index, let make it zero based, no? Because I wrote my code zero based earlier, so starting from 0. Okay, so now it's sort of this thing, but instead of current index, okay, current, yeah, all good. I'll make it help index. Okay, so call help index initially is at 0, and while help index is less than this index, then you don't need this. You make your help node equals to help node dot next, and plus now all is good. For now, I not removing. Let's just keep it here temporarily. So this is your helper node who has moved whatever distance, and now you want to move this helper node till the end of the list. So while help node dot next is not equals to null, right? When it's not the last node. Till then, you want to travel and you want to do this thing. So let's call all of them. Let's do this. Let's do this. Let's do this. And you don't need current index here, right? So okay, current index is removed. This is removed. This is removed. After you come out of this while loop, you have your previous node and current node at the right places. But you have to do this also. Help node equals to node next, right? And then now you have to see only one thing, which is you're on the node, and that node that you have to remove, that current node, if current node equals to head or previous node is null, whichever, then you just return head dot next, right? And otherwise this. Okay, let's see if this works. Sample test cases. Works. Submit. All right, that works as well. Cool.